Okay? What should all of the angles inside of those four-sided shapes add up to be?
360.
360 degrees. Okay, so if this is 1, 2, 3, 4, measure angle 1 plus measure angle 2 plus measure angle 3 plus measure angle 4 add up to be 360 degrees. Okay? That's one of our things that we know. Another thing that we know, and I'll add this onto the next slide and it'll match your guys's, if you actually want to flip to slide, or your slide 2 on your paper, that's this guy. I'm just writing all these things down now. I erased mine here, which is why I'm doing it here. Okay, so they add up to 360. Okay, there's another thing that we know about parallel lines, or parallelograms, is that this guy and this guy, those two measures
Like the supplementary
equals 180 degrees, or are known as what are called supplementary angles. Okay? So we have an if-then statement that works with all parallelograms, or all parallel lines even. Because if I was to extend these out, then I've got parallel lines, right? And I've got a transversal that intersects those. Okay? Angle 1 to angle 2, does anybody know what those would be called? If I jump from 1 to 2, so there'll be supplementary lines. So if, what would those angles be called? So going 1 to 2, does anybody know what those are called?
Linear pair.
Not a linear pair. So if I'm looking at angles 1 and 2, they have a fancy name. 1 and 2, or 2 and 3, or 3 and 4, or 4 and 1. They have a fancy name that for those that have gone ahead, they know what they're called. They're called consecutive angles. So if two consecutive angles, sum to 180 degrees, in other words, they're supplementary, then the lines are parallel. Okay? And vice versa. If the lines are parallel, then consecutive angles are supplementary. Okay? So those are two of the two concepts that we have that are new. Okay? Because of that as well, if 1 and 2 are supplementary, and 1 and 4 are supplementary, what does that mean about 4 and 2? They're congruent. Because if they're supplementary to opposite things, if they're supplementary to the same angle, then that means the angles are congruent. So that's an idea. It's kind of like a transitive property, right? If this and this give me something, this and this give me the same thing, then these two are congruent. Okay? So it's kind of like one, but not perfectly.
Why isn't it?
Why isn't it a transitive?
Yeah.
Because transitive means that I'm saying that two things are congruent or two things are equal to each other, right? And I don't have that situation, which is why I can't call it a transitive.
Yeah.
Because I'm saying 1 and 2 are supplementary, right?
Yeah.
1 and 4 are supplementary. What does that tell me about 2 and 4? That they're congruent. They aren't going to be supplementary. If they were supplementary, then that I would be able to say, okay, well, that's kind of a transitive type property because they're equaling to the same thing. But this plus this equals 180. This plus this equals 180. Well, since they're both using angle 1, we know that 2 and 4 have to be congruent because they're equal to the same corresponding angle, or part of them connects to the same supplementary angle, not corresponding, sorry. Okay, so what we're going to do now is prove, so given pieces, so this will be similar to the triangles and stuff that we've worked on, and then I want to prove that this is a parallelogram. Okay, so I'm given WX and YZ are congruent. I'm also given that they're parallel. So with all of our proofs, what do we always start with?
Given.
Our given. So I'll write down my givens first. WX is congruent to YZ, and WX is parallel to YZ.
Wait, I got
Okay? From there, what's something that I know? It's something that we used a ton.
Oh. W and Y.
So WY is congruent with itself, right? So WY is congruent with WY
Reflexive.
by a reflexive property.
Reflex.
What was that?
She just asked if Y is opposite.
Yes. Sorry. I was like, yep, should. Okay. From there, I've already marked it, but why have I marked that angle 1 and angle 3 are congruent?
For alternate interior angles.
Because they're
They're alternate.
Alternate interior, right? I know these two lines are parallel. Here's the transversal that cuts it. So I know 1 and 3 are congruent because if parallel, then alternate interior angles are congruent. Okay? So I'm going to go ahead and I'm going to come over to this board and finish the proof. Okay? It's not ready to yet send a proof. Okay? So now, what do I have?
Now you have hold on. You have 1, 3.
So I've got this guy, and this guy, right? So I have a side angle side. So I can say that triangle, okay, be super careful when you're labeling these triangles. I had a lot of people get these parts wrong or these problems wrong because they were labeling their triangle not properly, okay? You can start with any location you want. So I'll pick whichever triangle I want to start with and I'll call it whatever I want. Okay, I'm going to do XWY. Okay, this triangle is congruent to another triangle. Okay, I have to have the order similar. This X for the other triangle is similar to Z. So I'll start with Z. W is attached to the angle I know, right? So I'm going to go next with Y and then end with W. Okay? And that's by side angle, side triangle congruency. Okay? From there, now that I've said that the triangles are congruent, what other part do I know is congruent of my other triangle?
Don't you have to do like the
Slabs.
I'm going to use a CPCTC for my next thing.
Because congruent.
Because congruent parts, so corresponding parts of congruent triangles are congruent. Okay? The reason I'm going to use this is because I'm trying to prove that we have a parallelogram, right? So if I can show that these two are parallel, then I'm good. Okay? So if I use CPCTC, I'm going to say angle 2 and angle 4 are congruent. Because I know corresponding parts of congruent triangles are congruent. Okay? And now that I've said they're congruent, those two angles are alternate interior angles for the parallel line, or for what could be parallel lines X and Y. And if I know they're congruent,
So then why wouldn't you put it as if parallel lines are alternate?
because I don't know that W, Y, and X, Y, and Z, W are congruent or parallel, right? The only ones I know are parallel are these guys. And these are the alternate interior angles for that. Now that I've shown that these are congruent, if alternate interior angles are congruent, what do I know about the lines? They're going to be not congruent, they're going to be parallel. So now that I've got this stated, I can say that XY is parallel to WZ because if alternate interior angles are congruent, then the lines are parallel. Okay? So that means now I could come here, I could do this if I wanted to, and mark these guys, and now I can mark parallel here and here. Now we've got two sets of parallel lines, right? And if I have two sets of parallel lines, what do I know this shape is? Parallelogram. So now I can say XWYZ is a parallelogram. And I know that that's true simplified definition of what a parallelogram is. Parallelogram. Okay? Questions?